we had to build an alert because every once in a while, folks would release debug logs to production. Right? It was just like a thing. A team would not. They would have debug log flag turned on in dev, and then they would accidentally do it in production. And you can denial of service attack yourself on accident.
Hey there, welcome to Book Overflows, the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toups. How are you doing, Nathan? Well, as always, make sure to like, comment, and subscribe. Leave a 5-star review. If you're on an audio platform, share the podcast on LinkedIn with your friends and coworkers. And if you want to chat with Nathan and I more, you can book a coaching session with us on Leland, and the links to that are in the description. Nathan, you are in a new location this week, aren't you?
Yeah, and I'm still moving in, so hopefully it's not too echoey. But if it is, I apologize. But yeah, this is my permanent office that I'll have set up. So excited.
There we go. Yeah, you might hear a little bit of echo, listeners, but that's just what you get when you move in. We recorded from lots of places. We recorded from hotel rooms, from a work phone booth, from this is a versatile podcast. Well, speaking of versatility, we got a lot to talk about this week with the back half of Mastering OpenTelemetry and Observability by Steve Flanders. Just give you a quick introduction on Steve Flanders again. Steve Flanders is a founding member of the Open Census and OpenTelemetry projects and has over a decade of hands-on experience in the monitoring and observability space. As a senior director of engineering at Splunk, a Cisco company, he oversees the Splunk observability platform and spearheads Splunk's OpenTelemetry contribution. He was previously instrumental in building what is now the Splunk APM product at Omnition and the Log Insight product at VMware. A sought-after speaker and blogger, Steve frequently shares his insights at prominent conferences like KubeCon and on his blog. He holds an MBA from MIT, underscoring his blend of technical acumen, strategic vision, entrepreneurial spirit. I feel like I used to hear a lot about Splunk, and I don't hear as much about them anymore. Do you know people who use a lot of Splunk?
Most of the folks that I know of are in big enterprises, and they've had positive experiences with them in the past, and it kind of comes with them.
Yeah.
I wouldn't be surprised if they're trying to reinvent themselves. Is probably why they have folks like Steve Flanders, because
right.
They were around before OpenTelemetry, and then this book makes a really strong case that, and I think they talk about this later. We'll get into it, that like not supporting OpenTelemetry is its own form of tech debt, and so I have a feeling that that's what's going on. But I haven't paid attention to Splunk in a while.
I remember when I used them way at the beginning of my career, they were big on like logging and kind of like we were talking about last week, the old way of like getting metrics just by like parsing logs. But maybe that was just one pattern that my team knew how to do. Anyhow, because we know that that's not the pattern, at least that most people do, or it's not the recommended pattern these days. The recommended pattern is OpenTelemetry. And let me give you the book introduction real quick. This is Discover the Power of Open Source Observability for Your Enterprise Environment and Mastering OpenTelemetry and Observability, Enhancing Application and Infrastructure Performance, and Avoiding Outages. Accomplished engineering leader and open source contributor Steve Flanders unlocks the secrets of enterprise application observability with a comprehensive guide to OpenTelemetry, OTel. Explore how OTel transforms observability, providing a robust toolkit for capturing and analyzing telemetry data across your environment. Well, we finished the book this week. We did the first half last week, and this week we did chapters 6 through 12. Give me your thoughts, Nathan, on chapters 6 through 12 and maybe the book overall.
So this is one of those books where I really like it, but it's hard for the Book Overflow format. So meaning that we're slogging through these books. I think this book, you need to have some time to spend with it and do the examples and things like this. Also, 6, 7, and 8 were very technical and a lot of reference type material, and it was hard to listen to. I mean, hard to read. And but 9, 10, 11, and 12, those are like the meat of what I was excited about. And so when I got to those, I kind of perked up a bit. And so hopefully we'll dive into the latter half of the second part in this episode.
Yeah, the structure of this book is strange. It's almost like, so one, I agree. we just have to grade things on how they fit into the podcast format, which we recognize is not how a lot of people read these technical books. And I'll also say that some books, which I've since come to really appreciate, I had a really hard time reading. Working Effectively with Legacy Code was like that. Like, I remember the night before recording, like slogging through the end of Working Effectively with Legacy Code and being like, oh my gosh, what on earth am I doing? And that's one I think about a lot. I was joking with my coworkers. I'm like, it's a good day at work when you start thinking, maybe I should bust out Working Effectively with Legacy Code again. Take a look at that. But that's been a book that's been really foundational for me, but was a tough read. I think this book struggles with that a bit. There are some like weird decisions it makes. Like, I was really surprised where like in chapter 10, and this is a small thing, but I think it's kind of emblematic of like what's going on with this book. We're in chapter 10. He uses the word OpenTelemetry and then puts in parentheses again, OTel. And I'm a little like, this is chapter 10 of the book.
Right.
Like, it almost feels like it's like 12 different essays kind of cobbled together. I'm not exactly sure. I think it could have used another pass by the editor. And at any rate, lots of valuable stuff in here. Not great for the Book Overflow format, but we still think we learned a lot and are going to have a good discussion today.
Yeah, super excited.
Well, we're going to take a quick break, and then when we come back, we will discuss everything we have about the back half of mastering OpenTelemetry and Observability. And we're back. Thank you so much for tuning in. Well, we're going to talk about the back half of this book. Like we said, chapters 6, 7, and 8 are kind of like a deep dive on like how to use OpenTelemetry. There's a lot of code examples for a Python application. We're not going to talk about it really at all. And I think, I don't know, personally, I think I would have liked if that had maybe appeared earlier in the book. I don't know. So maybe like, I don't know. What do you think?
Yeah, I kind of, because we've read so many books at this point, we get to compare and contrast formats.
Right.
I love concept, concrete example, why this is important. Like that structure, kind of like how refactoring did it, I think, in a lot of ways.
Yes.
Because you can kind of skim, like if I don't really need to know the concrete implementation, I can skim that. Maybe I want to understand the concept and then like anti-patterns and, whatever, kind of like oscillate between those, because that helps me remember those things well. This book is structured a bit differently. I think if I had, like, now that I have this, I think I'd be more comfortable skipping around, because he also talks about this. He'll be like, oh, like we said in chapter 1, like he'll bring these kind of concepts up. But again, 6, 7, and 8, are very in the details. Like if I needed them for implementation reasons, I would do that. But otherwise, once we got to chapter 9 and through the end of the book, I think that's what's going to be the meat of this episode, is like talking about these bigger concepts.
Well, let's talk about chapter 9. Chapter 9 is all about choosing an observability platform, which is an interesting chapter because this book is all about not any particular observability platform, but OpenTelemetry. And I found it funny at how many times in the book's all just like, beware vendor lock-in, which, like, of course, that's what you'd write if you're, the inventor of OpenTelemetry. And it's just good advice in general. But that does let you do a chapter all about like, okay, as long as you're choosing a platform that supports OpenTelemetry, let's talk about all the different platforms you can choose, and let's talk about everything you should kind of consider when choosing a platform. So what stood out in this chapter to you, Nathan?
Yeah, so this one really starts thinking about like costs, both operational. They call it CapEx and OpEx, right? So capital expenditures, like infrastructure. OpEx is the operational expenditures. And, to do this responsibly, you have to kind of get into that world. Actually, when I was at the previous company that I was in, I was actually hired to be on the FinOps team. So FinOps is literally, we're big enough that we're having to think about the financial implications of how we're running infrastructure, how we're running observability. And it was interesting. This book gives a framework to say that companies will spend between 1 and 15% of a good threshold is 1 to 15% of cost of goods sold. They call it COGS. And so it gives you like a little formula to kind of estimate what you should expect. And it's funny because some companies want to spend 0. right, on observability. And some companies give a good, healthy budget for 10 to 15% of their total spend. I think when we were talking to Datadog, they were like, "Oh yeah, you should spend 20%," and we were like, "Get out of here." Of course, Datadog would say that. But yeah,
now when we
like,
talk about cogs here,
yeah,
is cogs, is that including, that's not including salary, is it? Or are they kind of advocating like 15% of like cloud SaaS spend?
I thought it was. I don't actually know the best. I'm like not a finance person.
Right.
We were thinking about. I think a lot of times we were basing it off of total cloud spend, and like observability was like a function of the total cloud spend of kind of roughly what to estimate. There's probably more sophisticated ways, and again, somebody who's got an MBA, who's the author of this book, probably thinks in spreadsheets much better than I do. But there is some percentage. So the idea here, though, is that you should understand what a healthy amount of spend is and what you should expect. Now, if you figure out how to use a tool that costs half as much, that's awesome. But I think the company needs to have a budget, and that's the cool thing is that if you have a healthy relationship with observability data, you should have a budget. You should say, "Hey, I expect to spend up to this amount," and then if you can come under that, one of two things happens. One, it unlocks maturity levels that you didn't have access to, and we'll talk about this. Like, he gets into this idea of levels of maturity, which is, first you have your basic tooling, then you have some intermediate, more advanced, and more advanced. You can't get to the more advanced if you're like, and we'll get into anti-patterns too. So if you're using observability in really inefficient ways, no one's going to clear you up to use the advanced tools, right? Like, if you're blowing your entire budget capturing all of the trace data and you're not sampling properly, they're not going to let you get into like AI driven predictive observability analysis and stuff like this. They're just going to go, "You exploded the budget. Like, you can't do this." And I think I thought this was a healthy chapter, and I kind of perked up because I was like, okay, in the real world, I've said use observability data. I've made some recommendations on how we tool it up, but where does it go? Like, do we build this thing? Do we buy this thing? And how do we manage it? Right. And I think, again, this is another great section there.
Yeah, and they talk about that. They talk about this idea of like build versus buy versus manage. So build would be this idea that like, hey, just build your own platform entirely. Like, and I'll say, I don't think I've ever seen this. Have you ever seen someone kind of build like an OpenTelemetry collection platform kind of from scratch?
Not completely from scratch, but a lot of times when
Right.
I'll think of build, I also think I put self-hosting in that as well. So this might be that you have a Kubernetes cluster and you're just like, I'm going to run Elastic and Grafana and all of these things. Like, I don't want to pay for them. I'm just going to run them in my Kubernetes cluster. And the only problem with that is that you end up having to have an ops team that's very advanced, right? You're not only managing, because you get into that problem of like, who's watching the watcher situation.
Mm-hmm.
If your observability infrastructure is on your Kubernetes cluster and the Kubernetes cluster is being observed by their observability structure, what happens when that goes sideways? You lose both, right? So maybe you spin up another Kubernetes cluster to run your observability stuff. Okay, well then what's watching that? Like, and so you get into this like weird chicken and the egg problem. I've been in environments in which the ops team was quite advanced and they were able to handle this, or maybe their workloads were so large that it was the salaries to manage this was less than a Datadog bill, right? They would host that themselves and do those things themselves. But yeah, most people, and I think Carter, you and I are both in this camp, we're both pretty aggressive about buying over building. And so I think in most cases, you should buy, right?
And I agree. I think metrics, I am constantly shocked at the cost of like of metrics collections. Even like AWS, like it's expensive. Like I think every custom metric you upload to CloudWatch with and every a custom metric counts if you have like different dimensions on the same metric name. It's like 10 cents a month or something like that. And like I think when I like just kind of automatically set up OpenTelemetry to like export to AWS. Like, okay, just log everything, right? It came up with like 6,000 metrics, and that was before we had done like any custom ones.
I think they're like 30 cents a month.
Is it 30? I think it is 30 cents.
Yeah.
Yeah. And so, I mean, if you just run that math, it's like 6,000. I'm doing it right now. 6,000 times 30. I mean, yeah, it's like $1,800 a month.
Right.
And that was just our back end. I'm shocked by that. And then I know Datadog is known for how expensive it is too. I mean, what's been your experience with
it's the biggest thing
vendors?
where we're like, it's a couple of my jobs. I've been in charge of managing our infrastructure cost, including observability.
Mm-hmm.
And it's the most humbling experience because you do your best estimate, and then every month you kind of like open your email and go, oh man, that's what we really spent. And you get better at predicting it over time. But I'll tell you that like Datadog, and I keep calling them out, but it's okay. I've been burned by them a few times, so I'm going to call out Datadog. We ended up creating this very complex cost calculator because Datadog wouldn't provide it, right?
Oh,
they publish all of the data. So like I will say to AWS's credit, to Google Cloud's credit, and I would imagine Azure has something similar. They have these like pretty sophisticated cost calculator web apps. And you can even export them and do all this other cool stuff. But I leaned on those so much because you're like, there's a base cost, there's a utility cost. If you have backups, those are going to have a cost. There's like, if you're going to do regional replication, like you have to, as a cloud architect, which is a lot of work I've done, you have to kind of set the baseline. And a lot of times I would give myself a buffer. I would do like, depending on how good I was at that particular area, I'd give it, 25% or 50% buffer and say, hey, here's an upper bound. I think we can actually operate at this cost. And I got pretty good at estimating that. But if you're not, for the faint of heart, or if you, the other thing with like Datadog and telemetry is, imagine we had to build an alert because every once in a while folks would release debug logs to production, right? It was just like a thing. A team would not, they would have debug log flag turned on in dev, and then they would accidentally do it in production. And you can like denial of service attack yourself on accident. And so we had an alert, and we would actually like stop that because it would also be a huge logging expense. Like I think we blew through our Datadog logging budget in like 5 days.
That's crazy.
Because a couple of teams who had run stuff in debug mode had like uploaded stuff. And of course, it looks like amateur hour on our side if this happens, and we have to like do a postmortem and like figure out what to do next. So it's non-trivial. And I think that's why there's like so much of this cost piece in this book, is because, and this comes into anti-patterns as well. It's crazy. I think this is why their observability platforms keep popping up. Why there's vendors like I've talked about them before, but CoreLogix I've been really impressed with. Because they can operate at a fraction of the cost of what AWS does at scale. So when you're smaller, even $1,800 a month, it's not great, but it's not the end of the world. But let's say you get to 60,000 custom metrics, or you get to 500,000 custom metrics. That's where like it's not tenable to do it on AWS that way anymore, and you need to use something else. And because now we're talking about like annual salaries of observability teams and stuff like this. And so it's interesting. It's also constantly evolving. And I one of the things I do like about this book is that they kind of give you a framework for assessing the sort of viability of using a set of tools. So like if I'm using OpenTelemetry and a new technology comes along and they support OpenTelemetry, then we can switch to them with the least amount of pain, right? Like that's a pretty decent breakdown, because I think we've all felt this, where like you get into the Datadog ecosystem, or maybe you're on New Relic, or any of these other kind of like big players, or Splunk, where you get really used to their vendor locked ways of doing stuff. It can be like a multi-year transition if you're not careful and your company's big enough, right? And so I think these cautionary tales are really important.
Yeah, I've seen this transition happen at larger companies. The last company I was at had been a big Datadog customer, and then the bill just got too large. And so they actually did go and kind of build their own observability platform. And that's why I say when we talk about build versus buy versus the last one is manage. And that's where he talks about like, okay, this is you setting up Prometheus, setting up Jaeger, using these kind of open source components, because even at this big company I was at that decided to make their own platform, really that's what they were doing. Like they were self-hosting Grafana at scale. So I'm curious what that kind of like true build versus just managing looks like. But anyhow, I saw a company throw out Datadog and switch entirely to doing this kind of on their own because it gets so stinking expensive.
Yeah, it's kind of nuts. And I think there are some novel ideas that'll come out and kind of disrupt things from time to time. And that's cool. Most companies aren't that. And I would say that most companies, building it isn't interesting to your shareholders. It's not interesting to your users, unless your company is actually to reimagine how logs get gathered. If that's your business, then sure, like go for it. And maybe you can sell this product to other people. Maybe you've come up with, and I think we have seen some of this, like there are interesting platforms like Observe is one of them that I think it's founded by somebody from from Snowflake. And so they really understand data lakes really well. And so there's this idea that like we collect all this data and then we can do multi-pass processing on it. And we have this very efficient way of gathering things up. There's like all these interesting emerging patterns with these big data pipelines that are happening with AI and ML. Those are going to positively impact observability, because observability at the end of the day is time series data, right? All of this is time series data. There is a timestamp. It comes from some source, and it has some sort of context. And then OpenTelemetry, of course, gives us the way to correlate across these events. And so as technology advances for time series based data, whether it's Internet of Things or, stuff happening in the ML space, I think these innovations are going to like go upstream. And so if we go back to ideas of like building evolutionary architectures, which is I think is another kind of interesting thing to overlay with this book, are you building your observability system so that it's evolvable, right? We know that there's a trend, and they get into the final chapter in this book. They even talk about the future of where things are going and like all the new signals that they're interested in pulling in. And as those signals mature and as companies come to expect those new signals to like understand how their business functions, the tools to back it, the build versus buy versus manage, are going to be there. And sometimes that means you're going to have to self-host something because it's so new, there's no infrastructure and ecosystem around it. And then other ones are going to be new players that are coming out of Y Combinator that are, being like, oh, everything you think about signals is wrong. And it's these 5 signals that are actually going to make your business, like scale up and, use our tool. And you're like, okay. And you just, if you're in a way of embracing that and using those innovations when they're there, observability is just another dimension of like how you innovate in your own company.
Mentioning Y Combinator, I'm looking at. I want to see here. Yeah, I was looking through the Y Combinator batch recently, just like the most recent one, and I was just surprised. Let me see if I can. Yeah, I was really interested in this company because like everything in Y Combinator these days is like AI, like that's all it's doing. And so when there's a non-AI company, it really jumps out at me. This one, shout out to them, S2.dev. I was really impressed with this. That's their description. They say S2 is a serverless data store for real-time streaming data. The more we worked on data systems, the more we felt like there was a building block. The seamless experience of object storage simply did not exist for durable streams. So we set out to fix that. S2 reimagined streams as an unlimited and access controlled web source, like if Kafka and S3 had a baby. And then they advertise it for agents. They're building agents use granular streams to manage context real time, make workflows audible, and coordinate between agents. Anyhow, I don't know a ton about it, but
this is funny because this is actually tooling that we've been building out internally. This is conversations that I've had with folks. This is a real unsolved problem. And I think bigger companies have come up with these kind of like, Kafka things where I need an event stream, but I also need big associated data, because Kafka, is limited. I think it's up to like 6 megabytes by default and 20 megabytes, like if you pack it out, of like how much you can put into an event. But a lot of times what I want is actually a big blob of data stored in something like S3 in a reference to it in my Kafka stream, so that I know how to like get back to it. And then I can like look at these events over time and replay them and come up with, clients that consume this data. And if you look at that pattern again, that's time series data, right? Kafka gives us this like really clear way of saying, here's a sequence of events on a specific stream. This structure is increasingly important for the types of large scale data processing that we're doing. And observability is just a subset of that, right? Observability is a time series data stream that has meaning to the business. And typically for us, the audience is internal, right? Where the customer doesn't care. Where the customer does care is that if the thing that they're relying on from you breaks, are you able to, signal on this? And then ideally, are you able to predict that something's going to break before it does, right? And that's the real gold standard.
Well, he talks about that maturity framework, and there's 5 levels. Maybe we can review the levels just briefly.
Yeah.
It says level 1 is basic monitoring. Reading from the book, he says, at this level, organizations have basic monitoring in place, focusing primarily on uptime and system health. Monitoring is often manual, limited to simple metrics like CPU usage, memory utilization, and disk space. I think if you are using any sort of cloud provider, you kind of get this out of the gate. If you're even just deploying on a single EC2 instance, you'll be able to look at the metrics for that EC2 instance and get some idea of CPU usage, memory usage, things like that. I mean, nowadays, how would you even not be at level 1? Like, I guess if you're doing stuff on-prem, but like,
if you're doing stuff on-prem, or you're just not looking at it, right? So it could be that you have no discipline and you're not aggregating it. Like, you're click ops at your company and you're like, what's going on? And you go in and look at the EC2 tab and then scroll down to, health and metrics. And then you're like, oh yeah, our CPU's maxed out, right? So ideally you're at least taking that stuff and like shoving it into some queryable system that you can, at least put alerts on. Enhanced monitoring, I think, is level 2. Let me hear. Do you have it pulled up?
I got it. He says, this level introduces more detailed metrics and some level of automation. It includes application level monitoring and the initial use of more than one signal for diagnosing issues. I'm proud to say this is where I've taken my company to. We were level 1 before. We're now level 2. We've got some OpenTelemetry going. We've got automatic metrics for like our GraphQL requests. And then actually just recently, I was very proud of myself. We shipped a feature, and after we kind of got it all done, at the very end, I'm like, you know what? We should have some metrics around this. We should track, it's like it's like for redeeming discount codes. Like, we should track how many codes are getting redeemed, how many of those codes are failing. We've got we are a level 2 enhanced monitoring organization. That's as far as we're at right now.
For most organizations who have been struggling with this, it's low hanging fruit. And I think it's from like an 80-20 principle. You can do so much with just getting to level 2, right? Getting to enhanced monitoring, you'll learn a lot about how the business functions. If you have, for instance, SLAs, and again, an SLA, we're not getting too much into this for this episode, but like an SLA is a service level agreement. It's typically some sort of legal contract. Like, we promise the customer that we'll be up, 3 nines of availability, 99.9% uptime. That's a legal contract, right? That's just a declaration, and you say, we'll give you a partial refund for all minutes not up to that over the month or something. Internally, though, you need to be able to measure this. And so in enhanced monitoring, you might tie that to like what's called an SLI, which is service level indicator. This is the metric that lets you to measure what your SLO and SLA is. So these are the things that you would say like, oh, we measure uptime this way. This is how we measure it. So there's some tooling that goes into that. And so enhanced monitoring will get you into this. Like, when you work backwards from like, what is uptime for us? Is it just that the servers are up and running, or is it that we're not resolving, we're resolving 200s or 400s for all traffic and we don't do 500s or something, right? You're going to get into the world of enhanced monitoring. Once you get above that, though, let's say you want to not violate your SLA. You don't want to find out that you violated your SLA. You get into what's called level 3, which is proactive observability.
Yeah, this says organizations move from reactive monitoring to proactive observability at this stage. This includes advanced metrics, comprehensive logging, and the widespread use of tracing to understand system behavior.
Right.
So I have not gotten tracing working, but they go on to say kind of key aspects of this level include comprehensive metrics collection, centralized logging with advanced search and analysis, distributed tracing for understanding request flows, dashboards and visualizations for real-time insights and correlation across signals. Now, I will say, I think there's some overlap here with level 2, like
There is.
what is comprehensive metrics collection, centralized logging with advanced search and analysis. I mean, again,
Right.
if you're on AWS, uh, you get a lot of that for free. Distributed tracing, I mean, I think that, like we talked about, this is by far the hardest of the 3 signal pillars to implement. And then kind of dashboards and visualization for real-time insights and correlation across signals. If you're pumping your stuff into Prometheus and hooking that up to Grafana, you get a lot of that too.
Yep. This also gets into some like culture and behavioral stuff. I think one of the things too, if you read the Google SRE book, which is a great one, we should probably read that one for this podcast. Service level objective is sort of an internal set of tools that are typically stricter than SLAs, not always tied to SLAs, but a service level objective is we measure ourselves by like, this is healthy behavior for the company if we operate within this objective. And there's lots of ways of measuring ourselves. This is where you start getting into this idea of proactive. So we know that if we, our SLOs are met, that we're going to be well within the boundaries of our SLAs, right? We would like to have our operations, I used to do CrossFit. There's a CrossFit gym near my house, and we always talked about training beyond the standard. So like if I was going to compete and the expectation was to do like 10 pull-ups or something, I should train 15 pull-ups, right? I should train 15 pull-ups so that when I'm in competition and I'm tired from these other things, I can do 10 pull-ups, no problem. Proactive observability is that. It's basically saying I'm going to hold myself to a higher standard than what's absolutely bare minimum expected by the customer. And this gives us some wiggle room if things come up. And so, yeah, I think from a maturity standpoint, you look at that and go, yeah, that is a mature way of looking at things. And we should aspire to get there, right? So level 4, and I've only been in level 4 in a couple of companies. Most of the time, I think proactive observability is probably what I would call terminal observability for a lot of companies. It's like, okay, 95% of your value is coming from this. But if you want to be like elite level or doing things at like breakneck pace and be able to respond and react to them, level 4, level 5 is what gets you there. So tell us about predictive observability.
Yeah, predictive observability, as outlined in the book, is this level leverages ML and advanced analytics to predict potential issues before they impact the system. This level focuses on proactive problem resolution and optimization. Key aspects of this level include ML models for anomaly detection, predictive analytics for identifying potential failures, automated root cause analysis, continuous improvement through feedback loops. Sounds real nice. I don't think I've worked at a place like that.
Yeah, no, it's the tools are pretty advanced to do this, and you have to have a team that's like obsessed with doing this well. I've heard great stories, and I think companies like Netflix are a good example of this. This is where you're starting to get into like chaos engineering and all these other pieces. I know that a tool that Netflix used that's pretty famous was they had an ML tool that would constantly check access, like IAM roles. There's like a way that AWS resources have access to things internally. So you can have like an EC2 instance that's allowed to read and write to S3 buckets. And you make a role that says, yes, I'm allowed. And you want to make that scope to like a specific bucket and the specific like API operations. It would constantly have an AI tool that would check the config it had and then the actual calls it made over the last 15 days. And then say, hey, you're over provisioned permissions. Like you should actually like restrict the IAM role to this like lower level. You can do the same thing with telemetry. So you can basically say like, hey, we're gathering all of these metrics, but there's no alerts tied to it, or it's not tied to anything. There's no dashboards. Like imagine having these like predictive tools. And then also, I'll bring up CoreLogix again. They have a really great one, which is you can tell it to see your Git pushes to production. So like when I do a tagged release or something, I can say after a tagged release, if the error rate goes up more than 15%, automatically do a rollback of this release. So basically saying, hey, looking for these, I don't know what's gone wrong, but the error rate has gone up a bunch. Let's revert back and like send out an alert and just say, hey, look, something's wrong with this deployment. Those are cool. Like, again, most places don't have a rollback system that's mature enough to do automatically that you can't just do that. But if you do, you end up getting these like self-healing, tools that kind of come out. It's pretty cool.
We've got like rudimentary stuff set up with like immediately after deploys. We're on AWS ECS, and they have some tooling set up to, you can like hook it up to a CloudWatch alarm, and after deploy it like bakes for a certain amount of time, and then if there's an error, then it'll roll back. But I think that this idea of like kind of truly self-healing infrastructure, like it will detect, okay, wait a minute, one of the hosts has gone bad, let me kill it, spin up a new one. To be tying that not just to like a basic health check, but also like actual error rates. I think, again, like Netflix is kind of the example you hear about all the time here. I'd love to learn more about kind of how all of that works at Netflix, because really fascinating stuff. But I find that you can't really get to anywhere close to like a level 5 observability unless you're working at kind of like a pure tech, often a big tech company, where, I mean, like Netflix, I mean, that is Netflix's business. Like if Netflix can't stream, what are they doing? And so obviously there's a lot of observability set up around that to make sure that stays uninterrupted.
Yeah. And so let's talk about level 5, which I've never worked in an organization that has level 5. I was looking at it and being like, whoa, that would be so cool. But what is autonomous observability?
Yes. And I think I got ahead of myself. That's more what I was referring to with Netflix. This level represents the pinnacle of observability maturity, where systems are self-healing and capable of automatic adjustments. Human intervention is minimal, and the system can adapt to changing conditions dynamically. Key aspects of this level include self-healing infrastructure and applications, including things like Kubernetes operators and chaos engineering, automated remediation response using tools like runbook automation, use of AI or ML to dynamically adjust monitoring and alerting threshold, and fully integrating observability practices with continuous integration and continuous delivery CI/CD pipelines. So I think, again, some of these sorts of things, like you do kind of like, these levels are a little, they bleed through to each other a little more. Right. It's kind of like, like I don't think you need to be at level 5 to integrate observability with your CI/CD pipelines. That's kind of like step 2 for me.
We were, when I was at Flyer, which is this airline software company, we were at like 4.5, I'll say. Like it was the most mature SRE and platform engineering team. I was on the platform engineering team as staff level. We were always looking for things that could drive cultural change. And while I was there, I helped with some of the deeper, we were transitioning off of Datadog. We were on Datadog, but we were transitioning from Datadog native tooling into OpenTelemetry, and deeply tying this into CI/CD and getting better Kubernetes operator patterns. We ended up we built this really cool thing. One of the best DevOps folks I've ever worked with, he was like the Terraform master, and we had a Terraform that would provision Terraforms. So like you could spin up a project and it would build like a Terraform stack, but that Terraform stack could reference upstream stacks. So like if we made like organizational wide Kubernetes change, it would like matriculate through all of these SDLC pipelines and stuff. And we had really amazing control over it. But if you were working on a team, all you thought about was like your little slice of the universe. And and so you could zoom out as much as you needed to, but internally, and then we would provide all these modules like, oh, here's our OTel, observability module. If you use it this way, you get access to like this vast set of resources, and Datadog will automatically provision, and all of your namespacing will show up, and like really cool stuff where you're like, this is like nothing I've ever seen. And it was neat. And we were a pretty small company. I mean, we had, 700 employees total. I think it was 300 ICs. But the stakes were very high. We're, airline industry has very high standards. We weren't running like flight stuff. It was more like ticket purchasing and upgrades and, the add-ons like getting a hotel booked through the airline and things like this. But but they have very high standards for software just because they use it in other places with lots of stuff. So yeah, but that's the only environment that I've been in. It's like, again, we weren't even full on 5. We were like at 4.5. We had a lot of the predictive stuff. We're on the path to getting this like fully self-healing things, but tremendous amount of effort. I mean, if you look at the salaries, we were probably spending, several $1 million a year on efforts around this, right? And so, yeah.
Yeah, I think I would love to, if not work at one of them one day, at least do a deep dive with an engineer one day for someone who works at like a true level 5. Like I was saying, like Netflix is kind of, I think, the one you hear about all the time. Because
obviously Google, Google's going to be in there
right?
too, yeah.
But even as a, the cloud provider, like we weren't level 5. We weren't like autonomously healing. Maybe we were, and it was just kind of so, I don't know. We definitely weren't, because our on-calls were brutal. If we were autonomously healing, I shudder to think of what we weren't.
Right.
Of what it was picking up, because, oh my gosh, the pages were awful. Well, maybe we can talk about such a maturity framework. Maybe let's move on to chapter 10. This is one of our favorite chapters in any book we come across. We love a good anti-patterns chapter. This is called Anti-Patterns and Missteps. I was excited when this popped up. I was like, oh yeah. And so let's talk about some OpenTelemetry anti-patterns and missteps. We can't cover all of these. Maybe we can just give an overview of kind of what our favorite ones are.
Yeah, I like that.
I guess I'll lead with at least what Steve Flanders' favorite misstep is, which is vendor lock-in. That is the whole thesis behind OpenTelemetry, is instrument your application the OpenTelemetry way, and then that buys you the ability to swap out vendors underneath the hood. I'm a big fan of open source non-vendor lock-in. We talked a bit about this last week. Like sometimes I think it's a little more like we've been talking. I mean, yeah. Have you ever used AWS like Cloud CDK instead of Terraform?
Yes, and I regretted it.
You regretted it. Okay. I wanted to ask why, because we're at the point where like one of the big like promises of Terraform again is like no vendor lock-in.
Right.
But like we talked about last week, like really, are you really going to design your Terraform in such a way that it's completely cloud neutral so you can swap it out?
So if I were going to start today, and actually I am starting to, so me and a buddy are working on this kind of like open source idea. And nice. I've been a Terraform maximalist forever, since probably 2016. We're using Pulumi. And it's been a really have you heard of Pulumi?
I have not heard of Pulumi.
So Pulumi, imagine AWS CDK, but vendor neutral. So it is
interesting.
And not only that, but you can pick the language that you're comfortable in. So if you want to do it in TypeScript, if you want to do it in Go, if you want to do it in, you pick your favorite language. They have just an SDK. It has the idea of stacks, which is very similar to CDK. And it is much more, well, you can use, it's a Turing complete language. So you can do a lot more of the, like, if you need to like use loops and do the other kind of interesting things, make your own library that kind of like gives a lot of context or builds custom naming patterns. But I've been really impressed. Also, they've really embraced this idea of IDPs, or internal developer platforms. The goal for things like this is, I would like it if I had a really simple way, a template or something for a team to spin up a new project and it just be done right, So Pulumi has this ability, not only do you manage infrastructure, but you can also give this sort of like self-service pattern on top of it. And because it's just code that you run yourself, they have a Pulumi cloud, but you can also self-host. So, or I say self-manage, right? You can point it to an S3 bucket and the state is managed there. But I've been really impressed so far. And we're doing some weird stuff. Like I'm making it so that you can dynamically provision a Pulumi stack based off of some thing. And so like we're doing like dynamic runtime stuff with Pulumi. But if you want to use it more like Terraform plus your own custom code, it's super popular. And I kind of like had it on the back burners for a while. I had friends I respected who had like made the transition, especially when Terraform had the big falling out. I don't know if you heard about this, but like they changed their license and they made it so there's this like community version of Terraform called OpenTofu. And it was like not controlled by Terraform. And now Terraform's, of course, HashiCorp's owned by IBM. So people are like are they cooked? Or are they, or is there a future? And I'm not a doomsdayer. I think that Terraform has done some really important things, but I do think there's a need for these like CDK type patterns. I didn't love AWS's CDK because it uses CloudFormation under the hood, and CloudFormation I've found to be really frustrating. If you need to like, so one of the things I like about Terraform and one of the things I like about Pulumi is that if I need to import existing infrastructure and then use it to describe moving forward, it's pretty straightforward. It's not necessarily easy. Like you have to wrap your head around how the state works, but it's near impossible. At least it was 3 years ago when I was using it. It was near impossible, and we basically would just have to blow away entire stacks to like bring them back up from scratch, and we had to build our stuff out that way. And which is, if you're trying to retroactively describe a production system, it's like bad, really bad.
All that to say, vendor lock-in, no good.
Right. So, and so, if you're looking for an alternative to Terraform, I would look for other things. Like Pulumi again is like a new way of imagining.
I've never heard of that. That's really interesting.
You should check them out. It's worth a look, and it's pretty quick to get it. If you understand how Terraform works, Pulumi does do some things differently, but it's a less of a jump than if you're just starting from scratch. So, that's what I would do today. If I wanted something that was more expressive than Terraform, I would use Pulumi, like I am for this other project, which has been kind of a fun stretch for me.
Let's go back and forth here. So I'll say that's one of my favorite missteps or anti-patterns. What about you, Nathan? You give me one, I'll give you one. Let's play it back a little bit.
So this is one that's bit me, so I'm going to bring it up. So he gave 3 big categories. There's telemetry data missteps, platform missteps, which is where vendor lock-in is platform missteps, and then company culture. My 2 favorite, one is in telemetry and the other one's in company culture. So I'll start with this one and we'll do back and forth. Inconsistent naming conventions. And I know that's like the 2 hard things in computer science. It's like caching, validation, and naming things. This is doubly true because if you like, naming conventions are incredibly important, and you want one that gives you room to grow how a company describes stuff. And so you should spend some time on being like, should we namespace stuff and have like the org and the vertical and the team and all these other things? I would say don't just phone that one in. Like, spend some time thinking about how you want to structure your naming of stuff. It's not a death nail if you come up with a bad one, but you should have it well reasoned and it should be documented. Here's how we name stuff. Here's why. And it should kind of roughly break down to like how the company organizes projects. Otherwise, what you're going to end up doing is it'll be a free for all. And when you need to actually like filter by like, if you do a good naming convention, you can do things like put wildcards and say, I want all projects underneath this vertical in the company. And then boom, I have like these really expressive and simple, pattern matching queries. If every team's come up with their own naming convention, you end up having this like, if this, then that, like sort of if then statement that is quite cumbersome, lots of foot guns. And so you just, spend the time and come up with, and if you don't want to come up with yourself, go pick a company you like, go look at their technical blog and see how they name stuff, right? Like go copy somebody because they probably put a bunch of thought into it and probably came up with something that's pretty good.
That's funny. You talking about naming conventions, and like, we're just not big enough yet for that to be a huge concern. So I hear about that. I'm like, oh, I'm excited for the day we have that problem, right? Like we're just one team of engineers at this point. So mostly, we communicate by just yelling at each other from,
and a perfect example is like one of the first projects I did on that FinOps team came up with a consistent way that we actually tag stuff and annotate things, mainly so we could even just run reports for FinOps, right? Like it was just like, oh man, all these teams have solved their own problems 50 different ways. And so I had to go around and say, here's the way that we do things at Flyer. Here's the teams that are already doing it right or mostly right. And then I would go in and like open PRs across projects or encourage folks to come help. And then I remember like 2 months later, after we got 2 full billing cycles, and leadership was so excited that we could actually like measure things. And it was just because we came up with proper naming conventions. Like it's not like I did anything magical. It was literally just like, oh, some teams capitalize and some teams lowercase, or oh, they use this, but they attribute it to like a team, and this one the owner is a team, and this one the owner is like an email address. Well, which one are we doing? Like, what's the value of this? And again, as pedantic as it seems, these are the ideas that'll scale with your business over time.
Well, I'll give my next one. This falls in the platform missteps, anti-patterns. Alert storms. He defines alert storms as configuring alerting systems with excessive or poorly defined thresholds, which can cause teams to be inundated with a high volume of alerts, many of which are false positives. We talk about this a lot on my team, which the only thing worse than no alert is a noisy alert, an alert you don't pay attention to. I was actually really, really impressed with one of our junior engineers. I did a lot of work to set up OpenTelemetry and to get alerts going. And I defined the thresholds like pretty generously. Like, for example, one of our applications, like it's got like, I think I said like 5%, like 5%. If 5% of requests in a 5-minute period are 500 errors, that's a problem, right? And which again, I think is pretty darn generous. And that one was like alarming more than we wanted to. And he had kind of came up to me and been like, hey, this alarm, like it's too noisy. It's like, I agree that it's noisy. I just think 5% is a really generous threshold as is. Like, I don't know if we can tune that down. Like, we got to figure out why we're getting all of these errors. And he actually took it on himself. He created a ticket and fought to get time for it in the sprint, just to go and like audit all of our alerting and just see like, okay, why are these pretty noisy? And then he found out that like, yeah, those 500 error rates, like it was some random path that was completely non-critical and was like getting pinged as like part of like a secondary flow. And for some reason was returning 500 errors. And so I was really, really impressed with him. He set up like a separate staging alert Slack channel so that we could forward the staging, so we could separate out the staging environment and the production environment and not just have one alerts channel. Really, really impressed by him to take that on himself. And I think he's right, because like I just kind of set up a lot of this OpenTelemetry stuff like almost in my spare time. And so I didn't have a ton of time to go and fine tune it. So very impressive work by one of our junior engineers. And I think it's a great act to, you know, not having an environment with alert storms.
Yeah. We had this problem at one of the companies I was working in where, for whatever reason, they were using 500 errors to signal stuff. And I was like, guys, 500 errors are like the world's falling apart, right?
Yeah,
like, and for the uninitiated, I guess, we're a little inside baseball. HTTP codes are these codes that, you know, signal 200 OK. You maybe have seen this, you know, places. 200 OK means the response came back correct and it was proper. There's 300 level errors, which are typically around redirects. 400 are you know, errors or unauthorized, things like this.
Usually the client made a mistake.
Yeah. You know, yes, exactly. It's 400. Maybe you don't have access. Maybe you didn't, you know, whatever, or the resource doesn't exist. Things like that. 500 errors are literally there's like server errors, like something existential happened. Those really should be rare, and they really should be something that like you need to go check it out pretty immediately if something's going on. And so I was very pedantic about meaningful 500 errors. Like I would go in, I would do the same thing though. I'd be like, we need to alert on these, and they're like, oh, it's really noisy, and I'm like, well, we need to go fix it. We're either giving a 500 error when it's not needed, or something's really broken, right? Something's really broken and it's going to bite us if we don't fix it. So, meaningful, like, again, just like naming stuff, proper HTTP codes they're so important. It's just like good hygiene. Like you should know that you should, like, if you're building REST APIs and stuff, a 200 versus a 203, those matter, right? 300 versus a 303, those matter. 400 versus 403. Like these different error codes should have meaning, and you should put a little bit of thought into why you're returning what you're returning, because other people should be able to take that and say, you know what, I want to process this differently because it's a 401 versus a 403, or, you know, whatever we have going on. And so yeah, I do. I think that matters a lot. It's cool too, though. Like, I think that what you did was healthy, which was you kind of came in with a wrecking ball, right? Which is like, we went from zero to, I'm going to put something out there and I'm going to throw spaghetti on the wall and see what sticks. And then somebody comes in and goes, you know what, this is noisy and I don't know if I should actually pay attention to this or not. And then they fix it. That's a healthy org. I think.
Oh yeah. And I
Yeah.
told my team, like, I think someone at some point had referred to it as Carter's alerts, and I said, I'm like, they're not my alerts. Like these are the team alerts. I'm like, if you think they're too noisy, like adjust them. Right. And so I was really proud of this engineer. Like he really took that to heart and was like, okay, like, this is
this is I love this too, because this gets into company culture.
Okay, was that your other one?
Yeah, that's my other one. So
there we go.
Short-term thinking is an anti-pattern. And again, short-term thinking would have been, we'll just turn Carter's alerts off. Right? It's annoying. And then you're like, okay, cool. Yeah, failed experiment. And that was it. And we just like put a bow on it. A culture that says, no, we need these alerts, but maybe we can tune them, or we need these alerts, we can address this load. That's a longer term thinking. That is a let us maintain this system. It's a culture that it's really awesome that you have people in your company and that you were able to push back and say, these aren't my alerts, these are our alerts, right? Like our infrastructure is doing this. I just shined a light on it. And I love that, because that gets into this, I guess that kind of ties into this other anti-pattern thing, which is lack of ownership and accountability. Mm-hmm. You kind of have to have these together, which is, and I've been in those organizations. Have you been in those where like everyone just kind of throws their hands up and you're like, oh, the lack of ownership piece. Yeah.
And, it's interesting. I can't remember which chapter it is exactly, but there's a chapter which is kind of all about, like, I think it might be this anti-patterns and missteps, but basically like how to convince leadership that this is valuable. And like, I think that's a good skill. Like, I think you should be able to convince leadership this is valuable. I'll say it's really, really frustrating working at a place when you're trying to get leadership on board with like basic ideas like this. Like, that's something I've liked about doing Book Overflow, is that, and I've said this before, I mean, we learn a lot of new stuff from here, but more, I think the better value I get out of this podcast is just hardening my ideas around what quote unquote good is. And like, I think there's a lot of interesting questions to ask around OpenTelemetry when you're implementing it as an organization. Like, what should our alerting thresholds be? Should we be doing automated rollbacks, or should we just be using these kind of get some observability? Should we be selecting a real deal telemetry provider, or should we just be kind of self-hosting using like Prometheus and Grafana? Lots of interesting questions, lots of there's not really right or wrong answers, but it just kind of depends on the context of your organization. But the question of, should we be collecting metrics? Should we be using those metrics to alert? And similarly, I think it's more or less a solved question at this point. Should we be doing OpenTelemetry to do all those stuff? Like, that's basically solved. And so I've really liked working at a place now where we're all agreed on what we want to ultimately get to. We're all agreed on these kind of basic principles. Exactly how you implement them is going to differ from team to team, environment to environment. And so, yeah, I think when you're feeling out new jobs, like, really try to work with people who are agreed on those high level concepts, even if they're not fully implemented yet. Right. Because it can be really, really painful trying to convince technical leadership to like embrace OpenTelemetry, because you wind up kind of like what you're talking about, like short-term thinking. It's just like, that didn't work, turn it off. Right. And I'm fortunate my team isn't like that. We say, okay, this is noisy, we should fix it, but no one's saying like, well, I guess we shouldn't use OpenTelemetry anymore.
No, that's so powerful. And I think, this lays the groundwork. Like you've taken a very pragmatic approach, it feels like, just from what you've described on Book Overflow. And it's one of those, again, it gets back into like Neil Ford, building evolutionary architecture, sort of pieces, that this is the foundation. It's well-reasoned, it's solid. We know that there's a lot of potential of where this can take us. And I guess actually this ties us into chapter 11 really well, which is observability at scale, right? So like, how does this stuff work as the company grows and as the things get more complex? What you build as a foundation and what you're relying on really, really matters. And what's cool is that you can grow into OpenTelemetry for it to become as complex as needed to meet the organizational needs. Was there anything in this chapter that spoke out to you, or is this just mostly a me thing?
No, I mean, this one I kind of was like, clocked is like, I'm not going to really care about this one right now. Like we're not there. We're not going to be there for a while. And, I think there's only so much information you can absorb at any given time. I had to kind of,
So I will say, as you grow, I'm hoping that Leland is wildly successful, that you guys are like, 3xing headcount annually, for the next few years or something. These things will come up. And I think that this chapter 11 will probably be something that you'll come back to and be like, okay, super neat. They start kind of addressing ideas on like, well, a lot of stuff has creeped in. Microservices is a good example. Why OpenTelemetry has become so important is because microservices have emerged as like a big pattern. Domain-driven development where teams are kind of owning their own little piece of the business and they're doing their own thing. But at the same time, I need this sort of, as we've talked about with Neil Ford, orthogonal coupling. Was it Neil or was it Kent Beck? I forget now.
Mark Richards. I mean, I believe this is I think it's a concept from Fundamentals of Software Architecture.
I think you're right. Actually, you're right. Yeah. And so this orthogonal coupling is this idea that like, hey, we let all these teams work autonomously, but we all agree on the language of observability so that there's a way for us to interface. And so this allows us to take the distributed system complexity and minimize the risk of how we observe this distributed systems. There's also like kind of a cool section, and again, I've run into this with that 4.5 company I was in, doing anomaly detection with things like z-scores and clustering and time series analysis, where we actually had folks who had analytics backgrounds who could come in and do deep data analysis on the behavior inside of our organization. And if you have the observability data, they can do that, right? If it's like nice, clean, well-formatted, well-named data, I can go get a data scientist to go analyze a process that we have. And what a cool problem to have. I loved it because I'm like, oh, we're doing like real science on top of like what we do. Like, some manager comes in and says, this is how we should ship code. And we can go, was that effective? Like, did you reduce the error rates in production, or did these things happen? Or did you actually increase the risk to the company operationally? We can go and analyze that and do cool stuff. So.
Yeah, well, maybe let's touch on chapter 12, the future of observability, just real quick. That's what's nice about this book having been written. I think this book was written in 2023. And so one of my favorite things, any theme park fans out there will appreciate this. The Carousel of Progress is like a little stage show of animatronics that Walt Disney made for like the World's Fair back in 1960s. And it's really cute. It's like a rotating theater. So like you sit in the seat and then the stage in the middle is stationary, but then your seats kind of rotate around the stage. And so it's divided into like 5 different sections and so you'll get a different section. It's charming. I really like it. But what's so funny is that like each section, it follows the same family, like as time moves on. And so it's like the family starts in the 1880s and it's like the 1900s, the 1920s, the 1940s. But then like the 60s were the present when Walt Disney made it. So then it just jumps from the 1940s to the future. And the future is like, I think they updated in the 80s, but it's still like an 80s vision of what the future would be. And it's so dorky. And I think they're redoing it, which will be fun. But anyhow, all that to say, like, you get that sometimes with the books that are written even like 5 or 10 years ago. It's like, now let's talk about the future. And then you're like, what is this? Like, this book does not have that problem because it was written in 2023. But we'll see. Any thoughts on the future of observability that stood out to you here?
So I remember there's a famous quote from Jeff Bezos in a fireside chat that he had about, people ask him what will change over the next 10 years. And he said the far more interesting question is what won't change, right? That people are going to want cheaper products and delivered faster. Challenges and opportunities, I don't think these will change, right? And so one of the things they outline these like 4 areas that they're all C's. So cost, particularly cost related to infrastructure and licensing of managed tools, complexity, and complexity overload, compliance, which is increasingly becoming a big deal with GDPR, SOC 2 Type 2, HIPAA compliance, SEC stuff, depending on whatever regulated industry you're in. The expectations just keep getting higher. The rules keep getting stricter. And then code, meaning, are you managing observability in the same way that you do SDLC, CI/CD, the other parts of your infrastructure? Is observability also in that domain. I think that those are 4 areas in which, like, number 1, all 4 of those would be great startup ideas. Number 2, you owning 1 or more of these in your organization, if you want to be an innovator when it comes to observability, diving deep in cost, there's a whole thing, certification track and everything called FinOps. Complexity has a lot to do with like developer experience. Compliance is its own track. Like you can get into the security and compliance world. And then code, of course, is also, again, platform engineering. These are huge opportunities. And some of this is complexity that we put on ourselves because like we kind of, OpenTelemetry kind of requires this and is pretty complex. But I think that that was sort of the groundwork of he outlined some trends. And so maybe you can dive into some trends that you see coming up, but I want to kind of give that sort of like that framework there.
No, I love that. And I really like that Jeff Bezos quote you shared about like what isn't going to change in 10 years. I think as far as trends, the one that stands out to me the most is obviously what everyone's talking about is AI. I think there's obviously like this really bold vision for how AI is used in that like it's autonomously consuming all of your metrics and it's also watching your alerting and then it's looking at your logs and your run books and it's kind of like automatically resolving things for you. I think that's $1 billion idea is an on-call agent, basically. I think, I mean, geez Louise, that sounds like a hard thing to build and who knows if that's even possible. But very interested to see the developments in that space.
PagerDuty is actually trying this. There's a few others, Firehose and a few other, Fire Hydrant. There's a few other of these like sort of companies that are focused on reducing mean time to recovery and support tickets and things like this. Again, unsolved. They're all kind of figuring this out. One of the things that I thought was really interesting and I keep seeing come up, there was an open source project and I guess a company now called N8N. I don't know if you've heard about them. Okay. So you'll see them more. They've kind of positioned themselves as like an Click, so like a GUI workflow tool. It's basically if this, then that you can self-host. And so you basically can say like, here's an agent and here's some stuff and like tie into all these other pieces. And then like you can build these low code, sort of no code workflows. What's funny is that N8N's been out for a while. They were doing some kind of cool workflow automation stuff, but they kind of had trouble figuring out exactly how to position themselves. And now that agentic AI stuff is out, they've repositioned themselves as like the tool of choice for folks who want to do, AI agent chatbots and all these other kind of more sophisticated workflows. It is genius on their side. Like I think that these kind of like workflow oriented architectures are going to become increasingly important with MCPs and all these other things that are happening. Another one I'll bring up is a little inside baseball is eBPF. eBPF, are you familiar with eBPF?
I'm not.
Okay, cool. So this is one of those magical things that happens kind of under the hood. But eBPF originally stood for Berkeley Packet Filter. It was originally a way for you to put, to do processing of packets in the kernel of a Unix-like operating system. And it would basically be in this like special place, but it would get priority. So it's very, very efficient, but it's not Turing complete in that you can't write like infinite loops. It has this little solver that makes sure that you're doing something very efficient. So you can say, anytime network traffic on this port comes through, do a thing, right? And it goes and does it. And then like it's in the hot path of this stuff. And so eBPF has become huge for telemetry and observability. Kubernetes, if you're using there's a Kubernetes tool called Cilium. And if you use Cilium, which gives you this high performance monitoring and security framework on top of Kubernetes. And so I would say anybody who's using Kubernetes these days should probably just default to using Cilium. And what makes Cilium so magical is it uses eBPF under the hood. And it can do amazing things with observability of the containers and all this other stuff without the performance hit that you would get when you would like traditionally use like a sidecar and using containers to monitor containers and all these other things. It's super efficient and it's those kind of technological breakthroughs that I think are going to have a huge impact on observability. So that's why I kind of like I'm riffing on eBPF for a hot second.
Interesting.
Yeah, it's really cool technology, regardless of whether you're using Kubernetes or not. And you'll see this a lot of. I think for most people, eBPF is going to be invisible, right? Like you're not like most people aren't thinking about like what's the Linux kernel driver that's doing TCP routing or something. Like you're not thinking about it. You're just like, hey, get a socket open and send traffic to it. eBPF kind of is a lower level tool, but yeah.
Well, I think that about takes us through the content of the book. Maybe let's wrap up with our usual. Give me your hot takes, Nathan. We now finished the book. We are fully qualified to give hot takes.
Yeah. So my hot take is really like after sitting with it for a week, I think that your observation last week on the Taylor Swift thing, which is like, who is this book for, is doubly true. So like we focused this whole episode on chapters 9, 10, 11, and 12, right?
Mm-hmm.
We read 6, 7, and 8 before that, and they felt like very different audiences. Like they felt like very different audiences for those. And I think the biggest value of the book was 9, 10, 11, and 12. Like that by itself could have been a book. And I think I agree. And so, I didn't know if I fully agreed with you last week, because I think the first part of the book kind of spoke to me a bit. Mm-hmm. But then I really understood where you were coming from, because I had a hard time getting through 6, 7, and 8. Like, and I mean, this is my like subject matter expertise. Yeah. I was like, man. But yeah. So that's my hot take.
Yeah, I feel the same way, and I'm just checking real quick. Like, who was this book published by?
Oh yeah, that's a great question.
It's a Wiley book.
Interesting. Yeah.
And I mean this, like, I don't know, like this book read to me like it was self-published. Like there was just a lot in here where I was like, again, I mentioned it kind of up at the top, like why in chapter 10 is it like telling us again, like, oh, OTel is the abbreviation for OpenTelemetry. I'm like, did the editor not catch this? Like, it doesn't flow well in parts. Like, it's confusing who this book was written for. Again, like all of chapter 1 is kind of like the history of OpenTelemetry. It's really hard for me to like, just like what I can say about this book is that confidently that this is the most comprehensive book there is out there about OpenTelemetry. Who I would recommend it to is just, I guess, like if you want to know literally everything about OpenTelemetry. I wish I could say a little more like, oh, this is perfect. This is OpenTelemetry for beginners. Read this and it'll get you kind of up and running. Or this is for your experienced SREs who really want to contemplate more about like the economics behind OpenTelemetry, the future of OpenTelemetry, some of the nitty gritty behind the scenes of OpenTelemetry. But like, instead, it's like this jumble of everything, and it makes it kind of, it's a tough one to recommend, and not because it's not full of great content. It is full of great content, but it's organized a little strangely. So I think this could have used another pass through by an editor, but still a good book. And I think it's definitely going to motivate changes in our career. Nathan, what are you going to do differently in your career, having now finished mastering OpenTelemetry?
Yeah. Again, I love the anti-patterns section. I think using this to call out anti-patterns and pitfalls to leadership. So if I see that we're going on a treacherous path, having this book, which is unquestionably the authority on OpenTelemetry, and saying like, hey, this is what we're doing is actually identified as one of the anti-patterns, and this is why it's dangerous. And actually there's some tactics. Like, I think we should move this other direction. It's just nice to give you like this little air of authority, showing that, hey, this isn't me just saying like, I don't like this, or, with the frozen caveman problem or something else, me just kind of being freaked out. It's like, hey, OpenTelemetry says, do not use it this way. Or, hey, this is a pitfall that you're going to run into. I think I'm really happy that I'll have these to kind of lean on.
Nice. For me, I just want to be better about demonstrating business value with OpenTelemetry. I think, Yeah, I really want to be careful. Like I'm fortunate to work at a place where there is a lot of leash granted for like, hey, let's just improve our technical processes. But at the same time, the only reason we improve our technical processes is because it helps us generate business value.
Right.
And so I just want to be good about kind of showing like, that's why I wanted with this new feature we shipped to add some OpenTelemetry metrics for it. So I can kind of show like, see, look, now we're getting more insight into this kind of new feature we shipped, and this feature has kind of like an outside partner, and so it's good to have to kind of keep ourselves accountable. I'm actually doing this with CI/CD. We do a monthly demo day where engineering demos for the whole company, what we've worked on, and so I kind of teased last month that the CI/CD stuff we were working on, but this month I actually took the time because I had basically like 2 clean months. I'm like, okay, let me compare our deployment metrics from last month to this month, and so I ran some Python scripts and got like basically like our change lead time. So like last month the change lead time so when a change was merged into the main branch to when it actually made it out to production we averaged 20 hours last month, and then we have now gotten it down to 47 minutes. And so I'm going to kind of demonstrate to the company, like, and I've got some other metrics with that. Like, hey, look, we've got 97% reduction. We're getting features out to customers faster. We have fewer regressions. So yeah, I think that's just a whole space I've been thinking about. And I really want to apply that thinking to OpenTelemetry. And then finally, we get who we would recommend this book to. Nathan, like I said, it's kind of hard one to recommend, but what do you got?
Yeah, so I dropped software engineers from this general SWEs. This book is really for platform engineers, SREs, DevOps, folks in software architecture, who really need to super deep dive into OTel, both the context and history, where the project's going, the proper best practices as it stands currently. If you're tasked with being a deep expert in OpenTelemetry, like this is a phenomenal book for that. But
yeah, and I would agree with that. And I'd also say, like, give yourself permission to skim parts of this book.
Yeah.
We can't do that because we're Book Overflow and we have to read the whole thing. But there were definitely parts where I think if you are like an SRE and you already know how to like do basic OpenTelemetry implementation, like you don't need chapter 6, 7, and 8. Like you can either skim them or skip them entirely. But yeah, we're glad to have read it. Glad to be moving on to other books. We're doing React. I can't remember the name exactly, but we're doing a deep dive on React these next couple of weeks, which will be a lot of fun. And thanks for sticking around, everyone. You can always message us at contact@bookoverflow.io. You can find us on Twitter @BookOverflowPod. You can find me on Twitter @CarterMorgan. And you can find Nathan and his work with Functionally Imperative at functionallyimperative.com. Thanks for sticking around, everyone. We will see you next week.
See ya.